Hello, can you hear me now? Yeah, so power cut and one class. You can get out. Can everyone join? Can everyone? Uh, as I said, the numbers, real numbers can be divided into two types. One is a fixed point one, and the other one is floating point. Okay. For the fixed point consists of an optional plus or minus followed by two unsigned integers separated by a decimal point. So as I said, this will be the format of fixed point. Okay. So in here, we can see this part we called as an integer part, and after the decimal point we call as a fractional part. So already we have seen all these DIs are the decimal number 0, 1 up to 9. And of course, the D1 is equal to 0. And I can take the number values 1, 2, 3 up to n. And J also can be greater than 1. It means 2, 3, 4, 5, like that. Okay. So let's see one example on here. Right, for example, minus, let's use a minus now, 0.761. So we call this part as an integer part, and this part we call as a fraction. Also, this point we call decimal point. Yeah, hope everyone see. Okay, also, if it is a positive plus number, also we can say 238. So this will be the integer part, this will be the fraction part, this is the decimal part. So if you even like one integer doesn't have a decimal point also, we can say like this. This is one of the fixed point number system. Okay. So this is for the fixed point number system. Next one. Likewise, the next one we call as a floating point number. Also you can see this is also one of the example that I have explained. Floating point. The floating point form has the same option plus or minus sign, decimal point, and an unsigned integer. This is important. Multiplied by a power of the base 10. That is the difference between the question. I mean, fixed point number in the floating point. So floating means it has the same idea with multiplied by a power of the base 10. So you can see this example. If it is 125, the floating number of this one will be something like this. If they will put like 0.125 10 to the power, sorry, 10 to the power 2. Or they say, for example, we can so many Anyone doing now? So, what is everyone doing? Let's see one example for the floating number also. So, for example, let's say 0.125 to the power of 10 to the power 25. This is of course a number 12.5, but this is a floating point number format. This is a fixed point number. So that's the difference. So why we are having this kind of two different representation? Because some computers allow this one. Some calculators or some digital computations usages, they use different number systems. So that's why we need to know everything. So this is the floating point number system. This will be the fixed point number system. This also can be written as like this way. For example, let's say, okay, sorry, 1.25 10 to the power 1 also fine. Or 0.0125 10 to the power, what is that? If you are taking this side, this will be minus 2, something. 1. Okay, so 1 digits this way. So you can choose that, okay, according to the number what you need. So you can choose the 10 to the power powers. So just only need to know how to represent these numbers in the different ways. One is fixed point number. This is the examples of fixed point number. It has the integer part, decimal point, fractional part. Similarly, in the floating point part, the floating point can be written as an unsigned integer multiplied by a power of 10. So that's all thing you have to keep it in mind. Okay, now let's go to the next section. So is there anyone to join? So, okay, one joined. There are 93 people. Next one, little bit of interesting, but also a little bit of important one. We call it significant digits. So why it is important is some, the calculators or computer, it will only display some number of digits. Okay, some number of significant digits. Maybe four significant digits, 5 significant digits. According to that, its value will be little bit of changing. So we need to know how it is working and what is all about. Okay, let's see. Significant figures. Experimental numbers must be written in a way consistent with the precision to which they are known. Okay, what do you mean by consistent? Consistent means how they are acting on. Okay, how it's accurately they need it. And precision means accurate. Okay, you can find these term words synonyms also. Okay, experimental numbers. Experimental numbers means what? So why we need all these numbers and this much of digits and all. So if anyone, I think most of you, if you are doing any practicals in the chemistry or physics, another courses, you may encounter some instruments. So when you are doing some experiment, you may use the machines which are having some values. These values can be according to that that machines fixed for some significant figures. So according to that, we may get different values, different errors also. We can see that in the error section also, we can encounter these things. So that's what. So this experimental number must be written in the way consistent with the precision to which they are known. Right? According to that, how it should be, we have to write. So in the contents of one speak of significant figures. Okay, if it is significant we can also say figures or digits. Okay? Both are same words. Significant figures or digits, they have physical meaning. So physically, what they are meaning is, first one, all definite digits and the first doubtful digit are considered significant. So you have to know this one. Okay, so this one is definite digits or first doubtful digits. So what do you think? For example, okay, from this example, we can see. Okay. So next one, okay, let's see everything and then come back to the example that will be used. So let's first they say all definite digits and the first doubtful digits are considered significant. Second one, leading zeros are not significant figures. So leading zeros are not significant figures. And third one, let's go to the third one and come back to the example again. Okay, trailing zeros. So, waiting. And then waiting people. So, next one, trailing zeros are significant zeros. So you have to know leading zero not a significant figure, but trailing zero is a significant figure. So I will explain you what is leading, what is trailing. So just understand these things. They indicate the numbers precision. One significant figure should be used to report the uncertainty occasionally too. Okay, so first of all, let's see these examples. Okay. Okay, the one first. Okay, now, for example, let's see the first they say we need the definite digits. Okay, definite digits means it should be 0, 1, 2, 3, like that numbers. Okay. Second one, they say no leading zeros. Okay, no leading zero. Leading zero means, for example, let's say I have 7, 5, 2, 0, 0, 0, 0. Okay, so if they ask how many significant figures increase, we can say only the definite digits. So what are the definite? Not the zero, not they are not taking as zero. They're taking from 1 to up to 9 numbers. Okay, so this number, okay, this number, okay. So there are three. They say three significant figures only. These four, they are considered as a leading zero. Leading means it leaders. Leaders means what? It's going on. They are following. Okay. So these four are, they are not taken as a significant figure. The leading zero means this one. Okay. So to be next one, they say trailing zeros. Trailing zero means, for example, 0 0.0050830. Okay, this is one of the number. We need to add how many significant figures. So first of all, this one, okay, we have seen these three are, we say, okay, sorry, this is not a leading zero means this one, okay. Sorry about that. This one is a trailing zero. Trailing zero. Trailing zero. Sorry about that. So see this one. For example, 0.00. The next time I will take out the waiting room. Okay, so this time there are so many. So let me do that again. Zero point zero zero 0.050,830. So this is one of the number. We want to find the significant figures. So this is they called as a leading. Okay, leading. Leading means following. Anyway, that is correct. So not this one. This one. Okay, this is leading number. This is okay. This is okay. This is okay. This is also okay. This is we called as a trailing number. Trailing zero. Okay, this is leading zero. And this is trailing zero. And these three are non-zero. So these three are non-zero. So non-zero, non-zero, that means definite digits. So these are countable, these are countable, these are countable. This is we called as a in between zero. In between zero. So this is also countable. Okay. So I will tell you, not the trailing zero also they will take non-zero, and in between zero also correct. But leading zero they don't take as a significant figures. So that's why it's in the north. Okay. Let's go back to our module again. So you can see the first one they say all definite digits and the first doubtful digit. First doubtful digit means something in the from the measurement. If you take like for example, what you say 2, 3, 5, 1 or 2. You don't know 1, no 2, but you are putting 1. That is also countable. Or you are putting 2, other one put 3. That is kind of doubtful digits. We don't need to worry about that. So just take this down. All definite digits mean non-zeros are considerable as a significant. But the leading zero means the zeros coming at first. Okay, it is not countable as a significant figure. Then the third one, trailing zero. Trailing zero means coming back. Okay, in the after the non-zero elements, if there are more zeros, it's called as a trailing. Okay, ending zeros. So these are significant figures. And also, next one. So this one we can say all definite objects significant. This is not a significant. This is trailing zero significant. Other one significant figure should be supported. Significant should be used to report the uncertainty of occasionally too. So this is something according to the measurement. So we can see that one later. Okay. So see this example first. That is very important one. Okay. So if it is in this example, what do you think? How many significant digits? So of course there are no leading zero. So all these three are significant figures. So this is okay. So next one, this one. So it is a number 2, 3, 1, good. There's no number after the decimal. So you can say still there are 3. Okay, 3 significant figures. Next one, 2, 3, 2, 0, 3, 0, 1. So what do you think? This is non-zero, non-zero, non-zero. this one in between zeros. So everything are countable. Therefore 5 significant figures. Okay. So now how about this one? The last one. What do you think? So 0.06. These two, three are leading one. So no. So 1, 2, 3. So it's the zeros serve to move the decimal point to the correct position. Okay. So they say the zeros serve to move the decimal point to the correct position. So actually the leading zeros are in the floating point we can write like 3 point time 10 to the power what you can say minus 3. Am I right? 1, 2, 3. Isn't it? So 1 time, 2 times, 3 times, minus 3. Yeah. Okay. So this will be our. So from this, what you can say only 3 leading zero. Okay. Significant figures. Okay. All these this I mean decimal point is if you put in the correct position, it will give you the correct significant value. So I can I'll give you some example. Can you try for some time? See whether you can understand the significant one. First one, 8, 4, 6. Second one, 3, 5, 4, 6. Third one, can you write like this? How many significant figures you can find? So 5, 0, 0, 6. Fourth one, 500. Fifth one, 500.0. And here, let's say 6 1 0.00836. Seventh one 5.0830 times 10 to the power minus 3. Okay, can you find the answers? We can check. Can you put your answers in the chat? All your timing for the to end the lecture is recorded, so you have to join in the first and when the lecture start, you have to start joining. Otherwise, your attendance not countable. Okay, so everything will be in the recording. So you have to have join at first. From if it is 1 to 3, you should be 1 to 3. Otherwise, if you are like 2:30 to 3, it is not countable as a attendance. So be careful in all the lectures, not only mine. Getting only one answer. Can you type at in a one line and send me? One is what, two is what, like that. Type in a one line. So let me check. This is number 6. Okay? This is 6. Not a 0, 6. We got only 3 answers. That's the others. Make it fast. It's okay if it is wrong. Just send me. We can discuss how it's. 99 people there, only 5 or 6 answers. Yeah, from the mistake, we can learn. With getting some answers. Okay, let me discuss some easy part. Okay, so this is obviously very easy. So you can have this one is 3, that is okay. Okay. This one, yes, 4, that is okay. So this is also, this is in between. So you have, it should be countable. So there are 4, that is also. So this one, see the things, 500 dot. So I told you, it is, if it is like this, we have to count it as, okay, again, my meeting gonna be finished. Okay, anyway, if it is finished, everyone's, join it in because there is something wrong in there. Okay, so, okay, this one, okay, 500 dot means it only have 3, okay? As I said earlier, this will be, yeah, 3, okay? So what about this one? This one, simple, there are trailing also countable. So this will be 3, this will be 4. 1, 2, 3, 4. Okay, now this one, 00836. So these are leading one. So not countable. Only these will be countable. So 3. So check your answers, okay? So what do you think? This one is a floating point number system. So this one obviously 2, 4, 5. 7, 5. Okay. So check your answer. If it is wrong, just write down the notes and why it is wrong. Okay. Okay. Hope you all understand about significant figures. Okay. So let me do the summaries. Okay. This one. Okay. So that's all about, I think, the number systems. Okay. So we can go to the errors. So first of all, let me summarize what we have learned on the number system. Okay, number systems. It is a representation of the expressing the numbers. It's used to represent in the mathematical notations, representing numbers by using digits or symbols. Okay, these are unique representations which will be helpful to operate the arithmetic operations like addition, subtraction. So then, using this one, we can also so the representation has been indicated in this way. So decimal number system can be there are more than decimal numbers is digits. I mean binary. Binary has, for example, I think you may heard. Okay, so we are mainly focused about the decimal number system. But if it is binary, so you already know, no, by means. So by yeah, we have studied by in the group theory and everywhere by me too. Okay, so if it is see here decimal number 10 digits. 10 digit means including zero. Okay, that's a waiting. Okay, so including 0, 0, 1, 2 up to 9, there are 10 numbers. Okay, likewise, if you want two numbers, start from 0, 1. Okay, likewise, if you say octal means what? 8. Okay, 8 means you can say 0 up to 1, 2 up to 7. Okay, also there are hexadecimal. Hexadecimal means 16. 16 means 0 up 1 to up to 50. These are the hexadecimal number system. Okay, there are different kind of number system. We can convert decimal to binary and binary to octal to this one. Okay, everything we can convert to the one common form. Okay, so anyway, here we're gonna consider only about it. I mean the decimal. Okay, that's what we are using for our daily usage. Okay, decimal numbers. It is representing this way. N is equal to plus or minus. Sometimes if it is minus, you should put the minus. But for the plus, we don't use. But anyway, here for the representation study, we use a plus. Okay. So D1, D2, D3, Dn. Okay, n number of digits they have noted. So these Di's are numbers from 0 to n. And now D1 not equal to 0. Because if it is 0, we don't need to consider that one. We need to consider this one. So that's why they say it should not equal to 0. And m is the word length. Okay, how many? So 1, 2, 3, 4, like 5 numbers. So you have to cut down up to m is equal to 5. Like that. Okay. So I is a representation of 1, 2, 3. Okay. So that is and then okay, this one. Now next one we have seen how this decimal number system can be written in the base of 10. Okay, so like that. For example, you can see this example 1573. So this will be, you can go this way. This will be a 1 digit. This will be 1, 2. I'm sorry, this is 10 to the power 1. This is 10 to the power 0. This is 10 to the power 2, 10 to the power 3. So for that, they have used this one, m minus 1, m minus 2, m minus 3, like that. Okay. So this will be, I hope you will understand this one. Next one. Okay, so the real numbers. So real numbers can be represented in a standard two forms. So one is a fixed point form. So with fixed point form, I said, for example, this one. Okay, like this. So x1 is equal to 1, 2, 3 dot 7. This is we call the integer part. This is we call the fractional part. This is the decimal numbers. Okay, similarly, the plus minus comes. Also, if we go to the floating point chart, it is the number can be written according to the multiplied power of 10. Okay, for example, 125. 125 can be written as in this floating point form 0.125 times 10 to the power 2 or 1.25 times 10 to the power 1, something like that. Anything multiplied by the power of the base 10. Okay, that is recorded as a floating point form. Next one, okay, significant figures. So I have explained you everything. Good. Okay, so you can go through it. So let's start our errors. Okay. So what do you mean by errors? If you are, it is this numerical subjects is mostly useful in the calculation of computation experiment and in the point to point how to find the answer. That's the idea of this. Okay, there are two kind of solutions. One is exact solution. Exact solution what we have studied so far. For example, you say, for example, 2x equal to 2, then x equal to 2 by 2 is equal to 1. Like this algebraic, okay? We call it as exact. So numerical results means something we find point to point, okay? Approximating to the point to point how we can calculate exact mean here to here directly. But numerical means point to point, we have to divide and find. We can see in the later part. So if you are doing those, divisions and things, we may encounter so many errors. So that's what we need to know. The errors, what are the errors available, how to deal the errors and everything that we're going to study here. Okay. Okay, so errors mean the difference between the true value and estimate value or approximation value. So you can see. So you can write the formula errors equal to true value minus estimated value or approximated value. Okay. So this is actually the true value. Let's say 2.5. It's a 2.7. Yeah, 7.6. Let's say 7.6 is a actual value. But for the easiness, we have taken 2.8. Okay, because our significant digits actually 3 only countable in the machine. Okay, computation. So what is the error? So we have taken something bigger than that, isn't it? So that will be an error. So when you're doing, using this one and when you're doing some experiment, it will, after that one, it will give you a big error.